Hello everyone, welcome to the next part of chapter 7. So today we're going to talk about angles of elevation and depression. So this is actually very simple only, so do not worry. So this is what it means in words. So I'll say you just get these two down first. I'm going to use the picture to describe what it looks like and how it works. Okay, so what we do is we have two things involved here. We have the lighthouse, and let's say we have the plane. Right, so you can see that from the top of this lighthouse, if I look at the plane, I got to look up, right, because the plane is in the sky, right? And then if I look straight ahead, this is what I call the horizontal line, the so-called ground, or flat ground, okay? And then this angle, when I look up, is what we call angle of elevation. Now from the same, in the same theory, again, if we look at from the lighthouse point of view and then look at the boat now, you can see that the so-called ground is still the same, right? I'm still looking forward, straight line, and then but I look down. So see, it's from here I'm looking downwards at the boat. So this angle is what we call angle of depression. Okay, now so it's actually very simple, right? So from the other point of view, let's say if I say from the boat's point of view, if the boat is looking up at the lighthouse, you see that it's looking up, and again this is the so-called ground. When I look up, okay, so it's here, I'm looking up. That's why from the point of view of the boat, the lighthouse is in the air. So this is the angle of elevation for the boat. And the most important thing I want to highlight today is, you can see that this dotted line here and this dotted line here, they are parallel. I'm just looking straight ahead, right? It's the so-called, it's parallel to the ground, which also means these two angles are going to be the same. Now this is one of the most easily overlooked thing, that actually from the point of view of the lighthouse, I look down at the boat, and the boat look up at the lighthouse, is the same angle. It's just different names only, because it depends on whose perspective. Okay, so that is actually the only thing you need to know for this whole section. It's as simple as that. Okay, so let's try a very simple question. So over here, you can see that they even draw a diagram for you. How friendly are they? So we have 43, this height is 43, and then this angle, so as you can see that if you look at from ground level, you look at the top of the office is 43, so it draw for you, and then ask you this question mark. Okay, so this is actually just a simple right angle triangle. Now angle of elevation and depression is always about right angle triangle, almost always. Okay, so you can see that this is your basic Tuakaso. So if I use this angle, I need to involve these two sides. It's going to be tangent. So tangent 43 over question mark here. I want to make question mark the subject. This one goes up, this one come down. I'm at here, press calculator, done. Okay, so this one has the QR code. So I suggest you try it first, let's not see. And then if you can't do it, you can scan the QR code. Okay, so I'm going to go through the next example, which has no QR code. Okay, so this is quite a wordy thing, right? So we have the Ferris wheel, Singapore Flyer, and then it's on top of a terminal building, so there's something below here. And then the wheel is the diameter of the wheel, 150. So this is the circle, right? So the diameter is 150. They even draw for you, very friendly. And then the highest point to the ground is 160. So the whole thing, which also means that this whole this little gap here is 15 meters. Okay, then I say from A, the top of the wheel, you notice that there's a car on the ground, C, right, sports car, and then the angle of depression is 25. So that means this angle from here, I look down, this angle is 25, and that's it. So I'm supposed to find what distance of the sports car from B to A. So it's this distance here. Okay, so I put a question mark here. So this picture has a lot of clutter, a lot of useless things here. So what I do is I like to just draw purely the triangle we're talking about here. So I extracted this triangle here. Okay, I extracted it and I draw it myself. So this whole length is 165. this 25 is the same as this 25, so this 25 too, and this the question mark. So you can see once I draw the triangle, it's super obvious. This is your basic tuaka. So this. So tangent is equal to this over this. So the question mark, I don't put question mark because now we got name, right? So I put BC. So as with just now, this one goes up, this one comes down, press calculator, done. Okay, so after that they say angle of depression of the sports car from the center of the wheel. Now this center of the wheel is where? It's W. So they're very friendly, they even put down W for you. So same thing, I'm just going to redraw the triangle, but this time I only want this triangle, W, B and C. So you can see that it's W, B and C. So this length I just found it, right? So it's over here, 354. I put 354 first, and then this is the angle I need to find, right? Because it's the angle of depression from W. So it's actually this angle, but effectively it's the same. So yeah, this is the angle, right angle, and then this 90, where do I get the 90 from? It's because W is the center, right? So from here to the bottom of the wheel, this is going to be 150 divided by 2, so that's 75. And then the last part is 15. So how do I get 15? It's actually 165 minus 50, because 165 is the whole thing. I minus away the 150, which is the total diameter. I'm left with the 15 below. So this whole thing is 90. So once you draw the diagram, you realize this is just a sec 2 tokasu again, right? So this angle involving this 2 is going to be tangent. So in this case, I can't put question mark, right? I mean, I can put like angle BCW, but that's such an irritating thing to write. So I'm just going to let angle be X. So tangent X, this one X, is going to be 90 over this one, so this over this, and same thing. I want X, I need to tangent inverse both sides. That's the answer. Okay, so this one is a little bit tough. This question is quite tough and quite long. This is a classic exam question, but I have the QR code here, so you can settle it yourself. The next example, oh, there's no more example already. Okay, so after that example, which is pretty tough, what you can do is you can actually start to do your homework too. There will be these 4 questions, so take note of the page number. Okay, so hope you enjoy doing your homework too. Thank you and bye bye.